I want to talk about how we multiply numbers that are both written in scientific notation. And I put a reminder here of the format of a number in scientific notation. It's a number A, where A is just some number between 1 and 10. So it's not a two-digit number, and it's not a decimal. It's not like 0.93. It's got to be a number between 1 and 10. And 10 is always our base, and B is an integer, and it tells us basically how many times am I multiplying, or if B were negative, dividing by 10. So if I had two numbers, both written in scientific notation, for example, let's say we had 2 times 10 to the 6th multiplied by 3 times 10 to the 4th. This actually is fairly straightforward and kind of nice in that we start by just organizing the kind of base numbers. We say, well, 2 multiplied by 3 is just 6. And since our numbers are in scientific notation, our answer is also going to be in that. And what we get to do is we get to look and say, well, this was multiplied by 10 6 times. This one was multiplied by 10 4 times. So total, we have multiplied by 10 10 times. We just add 6 and 4. So we say times 10 to the 10th. So if I did another example, let's say I had 3 times 10 to the negative 4th times 1.5 times 10 to the 7th. You could say, well, just multiplying 3 times 1.5 is 4.5 times 10 to the, and again, we'd say, well, here we were dividing by 10 4 times. Here we were multiplying by 10 7 times. Negative 4 plus 7 makes a total of 3. So multiply the numbers and then simply add those exponents, because all we're figuring out is how many total multiplications and divisions did we have. Let me show you another example. Okay, so this problem seems pretty straightforward. Once again, we can just look and say, all right, well, 3 multiplied by 5 is 15. And then we'd say we have 4 multiplications of 10 and 9 multiplications of 10 for a total of 13. And it feels like we're done. Unfortunately, we have an issue. And that issue is, by definition of scientific notation, we should not have our base number be greater than 10, and it is. So we need to figure out how to rewrite this in a way that satisfies our scientific notation. The easiest way to do it is to simply say, I need it to be 1.5. So if I were to think, okay, it's got to be 1.5 times 10 to something in order to be correct. Well, here's how I think about this. If the decimal were here, and then I was told I had to multiply by 13 tens, meaning it would move 13 times, sliding the decimal back a place means that now it will need to move one additional time from what it used to. So basically, you'd have to say it's going to move here and then 13 times. So now we've added one multiplication of 10 to it. So this is the thing to be careful of when you're multiplying. It's not a hard concept. I mean, you just multiply the numbers and then add those exponents to figure out how many total times you multiply by 10. But you need to get it back to what scientific notation, the standard form of it is, which is a number between 1 and 10. That was the one wrinkle we had. Let's do one more like that. Okay, so you can see I've definitely made some other decimals here appear. So let's begin by just multiplying these two. 7.3 multiplied by 4.2 is 30.66. I just used my calculator to do that. 30.66. And right away you should notice that is not going to be our final answer. We're going to have to move that decimal. And then we've got 10 to the negative second and 10 to the negative 8. So essentially we're dividing by 10 twice here and 8 more times here. If we add those exponents together, we get negative 10. But obviously we're going to have to rewrite this. We should right away say, well, I want it to be 3.066. Like that. Now think about the fact that this negative exponent means I would have had to move it this way to make a very small number 10 times. We'll just 10 times. I've already moved it once. I moved it one time. I need that decimal to be between the 3 and the 0. So you moved it one time. Well, how many more times does it need to move? Well, it needs to move 9 more times. So this will be negative 9. So you'll notice in both of these cases, if you wanted to kind of come up with a rule, in both of those cases, I've increased the exponent by 1, from 13 to 14, and from negative 10 to negative 9. Of course, being as it's negative, it looks a little bit different, but I did increase it in both cases. I don't know that it's worth memorizing. I would just always think about, well, like this one, it was 13, but I needed to have that one additional kind of exponential move in order to get it to the form I want. Here, the same thing. I moved it here, and that decreased the number of times it was going to move. If this video helped you, please like and subscribe for more math help.